In this nugget, we will learn about host network type on Docker. When containers are run in host network, they behave just like any other process running on that host. It will use the host IP address and also the host TCP port space to expose the service running inside the container. There is no separate isolated network maintained between the host machine and the containers running on the Docker host. It's a simple configuration which makes it easy to use and troubleshoot. It does not perform any operations on incoming traffic, NAT or otherwise, anything else. Onto our Docker hosts, first let's inspect the host network with the docker network inspect host command. Now just like that, as in bridge network, this command will give us the information about this network. As you can see, there are no containers on the host currently which use this network. Let's start 2 containers on the Docker host using the host network. We know that by default, bridge network is used by the containers. In order to specify a different network, we need to make use of the -net or -network option. We will run one Tomcat and one Nginx container. So docker run itd rm -net, this time we'll use, equals to host let's mention the name of the host, Tomcat2, and we will be using the Tomcat latest image. Okay, the container got started successfully. Now let's start the Nginx container. Similar command, docker run itd rm. We will use the -network tag this time. So network host -name equals to Nginx2 and the Nginx latest image. So container got started successfully. That's good. Now let's again inspect the host network. Docker network inspect host. Now here you can see how now that there are 2 containers in running state which use the host network type. Similarly, we can inspect the containers as well. Say docker inspect Tomcat2 for the Tomcat container. So it is using the host network, right? Okay, it is using the host network. Similarly, for the Nginx container, docker inspect Nginx2. One thing you note here is that there is no internal IP address mentioned when we inspect these containers, as was the case with the bridge networks. I guess you have already understood the reason. With network types as host, there is no separate network maintained, right? So now let's access these 2 containers from the external networks. Okay, so if you have noted, we didn't publish any port like we did in bridge network. So let's do a docker ps and let's confirm this thing. So in port, we don't see anything mentioned here. The ports are empty. There is no need for publish as well, because the containers network stack is not isolated from the Docker host. Whatever ports are exposed by the container are available on the Docker host through its external IP address. So Tomcat should be available on port 8080, which is fine. We will check, and Nginx should be available on port 80. So let's do that. Nginxing, right, on 8080. Okay, this is for Tomcat, and let's also check for the Nginx, and which is also working perfectly fine. Now let's see what happens when we have multiple containers which use the same port running on the same Docker host. Well, what do you think will be happen? I believe that there would be some sort of a conflict because the requested port on the Docker host is already in use. On our Docker host, one Nginx container which is already running in host network. Let's run another one. Okay, so let's try and running this Docker run itd rm hyphen network equals to host. Let's give name as Nginx 3. Okay, so Nginx 3 and the Nginx latest image. Let's check if the container is running by docker ps. Let's type docker ps. I don't see it running. Let's check docker ps -a if it is in stopped state. -a. There is no Nginx 3 there as well. It seems somehow it got killed. Let's run it without the detach mode here. So we'll have to run it once again without the detach mode. Docker run itd. So let's just remove the D option here, which will be running it in non-detach mode. There it is, the error because of which the container is stopping. Bind to port 80 failed. Address is already in use. So that's all about the host network concept of the Docker. Though this is easy to use, it has its own limitations, and that's why it should be used wisely. Hello everyone. In this nugget, we will see how to remove and add network to existing containers. Docker gives the flexibility to make changes in the container networks at runtime. We can remove networks or add networks to a running container without the need to restart it. Let's understand this through an exercise. We will run a Tomcat container with none as the network type, and then we will remove it and then add a bridge network to it. So we'll do it docker ps -a first before we start. Okay, so good. There is no container on our host which is in running or stop state. So let's start a Tomcat container on the Docker host now. So the Docker run itd rm net. We are going to create it with the none as a network type. So none, and the name will be giving as Tomcat exercise, say. Okay, and -p and mention the port as 8080 Tomcat, of course the latest image of Tomcat. Option P won't have any impact here because we are starting it with none network, but it will be used later when we switch to bridge network. Okay, so it's created. Let's run the docker ps and the container is in the running state as expected. We will inspect the container to check that it's running with the none network type. So docker inspect Tomcat exercise. We will use the container ID. Here it is. It's configured with none network type, as you can see here. Now next step is to remove the none network from this container using the docker network disconnect command. Onto our Docker host, let's run the docker network disconnect. Let's clear the screen a bit. Docker network disconnect none from the Tomcat exercise. This command removes the none network from the Tomcat exercise container. Instead of container name, we could have also used the container ID. Let's inspect the container again. So docker inspect Tomcat exercise. Okay, so as expected, there is no network interface configured on this Docker container at this point. Now we will add the bridge network to this container using the docker network connect command. Back to our Docker host. This time we will run the docker network connect bridge. Let's clear the screen and let's run the connect one. Docker network connect bridge. You're using the bridge type and Tomcat exercise. Now this command adds the bridge network to the Tomcat exercise container. As earlier, we could have used the container ID as well instead of the container name. So let's inspect the container again with this. being done. Docker inspect Tomcat exercise and hit enter. There is now a bridge interface configured for the container, and it has got an internal IP address as well, as you can see here. We will run the Docker PS to see the current status. Let's do that. Let's clear the screen once. Docker PS. Okay, we can see that the container is accessible to external network on port 32770. Let's try to access it from the browser, and there we can access the Tomcat over it. So let us just mention 3473.210.93 and the port number 32770, as we just saw. Okay, here it is working. So this is how you can connect and disconnect a network from the containers. In generic sense, an overlay network is a computer network that is built on top of another network. Nodes in the overlay network can be thought of being connected by virtual or logical links. Each of these links corresponds to a path, perhaps through many physical links in the underlying network. The internet was originally built as an overlay upon the telephonic network, while today the telephone network has turned into an overlay network built on top of the internet. With respect to Docker containers, overlay network is used for communication between containers on different hosts. It creates a distributed network among multiple Docker daemon hosts. This network sits on top of overlays, the most specific networks, and allows containers which are connected to it to communicate securely. Docker transparently handles routing of each packet from the correct host container to the correct destination container. Overlay network is used with multiple Docker hosts and can also be referred to as multiple Docker nodes, primarily used in context of Docker Swarm. In this course, we will deep dive into this topic when we cover the Docker Swarm. Hello everyone. In this nugget, we will talk about the custom networks. Firstly, we will talk about creating new networks. Then we will understand how the custom networks can be put to use, and lastly, how they can be removed. So let's talk about creating new networks. New bridge and overlay type networks can be created. Host and none networks are present by default, and no more networks of these types can be created. We can create new network with Docker network create command. There are options like driver or -d is used to specify the driver to manage the network. If you don't specify the network, it takes the default to bridge. We also have --subnet option, which is used to provide the subnet in CIDR format that represents a network segment. Okay, so having discussed that, now let's go back to our hosts here. Okay, first we will create two Dockers out here. First one, let's run Docker network create driver. We will give this as bridge and name it as new bridge 1. Okay, and which runs successfully. For the second, let's run the Docker network create driver is equal to bridge again. We will give subnet parameter also this time. So --subnet 172.99.11.0-24, and we will also give the gateway. So --gateway equals to 172.99.11.1, and we'll call it as new bridge 2. Okay, so now we will inspect these created networks. Run the Docker network ls to list all the networks that we have here. Okay, so all the available networks on the host are displayed here. We see that our created both networks are listed out here. Okay, so now let's inspect our networks. let's inspect the first network. Docker network inspect new bridge 1. Okay, so notice the subnet and the gateway allocated to it. Since we did not provide the values, they are configured by Docker itself. Similarly, we will run the inspect for the second network. So let's go back here and Docker network inspect new bridge 2. Here our provided values for subnet and gateway can be seen. Okay, now I will run the if config on our Docker host. Okay, so let's run the if config on our Docker host. Let's clear it a bit. As discussed earlier, the bridge network was represented as Docker 0 on the Docker hosts. Let's check for the newly created bridge networks. Okay, so here you can see these are two new networks interface which have been added. Both are prefixed with BR indicating the bridge network representation followed by the network ID. Okay, so we can also see the IP addresses provided to these interfaces, which is the same as the gateway IP address for the Docker networks. Let's go back. Now we can create as many networks as required on a host. Just like with the default networks, the custom networks can also be added to or removed from the running containers without the need to restart the containers. In case a container is connected to multiple bridge networks, then its external connectivity is provided via the first network in lexical order. Hello everyone. In this nugget, we are going to do an exercise with the objective to disconnect default bridge network and to connect new custom bridge networks to a container. Now let's first run an Nginx container using the default bridge network. So let's get back to here and run the docker run itd -rm -name. Test Nginx is the name we will use for this one, and then -net will be bridge on the port -p 80, and we'll be using the Nginx image. Okay, so let's inspect this container Docker using the inspect commands. So docker inspect test Nginx. Here notice the internal IP address provided to this container. We will run the docker ps command to see the external port on which it is available. So let's go here and let's clean it. Okay, docker ps. Okay, so the external port on which it is available is 32768. Access it from the browser on my machine. So the external IP address of the Docker host is 347321093, and our application is available now on the port 32768. Okay, so it is accessible. I will now create a new network here. So let's do that. Docker network create --driver, which is bridge. I will provide the subnet for this IP for this 172.99.101.024. Gateway also 172.99.101.1, and then new bridge 3. Now this will create new bridge 3 network with starting address as 172.99.101.1 and subnet mask as 255.255.255 and .0. Now I will disconnect the default bridge from the running container. Okay, so let's do that. Docker network disconnect bridge test Nginx. Okay, so let's check the external connectivity for this containers once this is done. So let's do, so I will do a refresh, and as expected the page could not be found, right? The page is not found because that thing is changed now. Now let's connect with the container to the newly created custom bridge network. Okay, so let's create that Docker network connect new bridge 3 test nginx. Okay, the command ran successfully. We will do an inspect on the container now. Docker inspect test nginx. Okay, so let's scroll up a bit. The driver is still bridge, okay, as you can see, but now it is using a custom network under it, which is new bridge 3, right? So the internal IP address earlier was 172.117.0.2 and now it is 172.99.101.2 as per the subnet range of the new network that is available here. Now let's run the docker ps command to check the port on which it is available externally. So as you can see, we have this. Now the port number has changed to 32769. Earlier it was 32768. On the browser, let's go here. We will try to access using the 32769, and here it goes. It works this time, right? So this way we see how to change the associated network for a running container.